Hello, everybody, and welcome back. See if we can get, okay, here we go. This is where we left off yesterday, and we will move forward today. This was where we left off. We had two gametes, each of them with 46 chromatid in each one. I'm not going to go through the review again. We're just going to move forward. If you don't remember what happened, go ahead and watch yesterday's video and see how we got to this point, but we are moving ahead. Okay, so we did meiosis once, and we're going to go through just about everything again, but we're not going to go through interphase again. Interphase only happens in the beginning. We have enough organelles, we have enough cytoplasm, we have all the DNA we want. So we're going to go through the whole thing again, except we're going to go through starting with prophase 2. Okay, and this is going to look just like mitosis. All right, so prophase 2, meiosis, prophase 2. All right. Now, each time we do this now, we're going to have to draw two cells because we have two gametes. And each of them are doing it. All right. So, since this is just like mitosis, let's talk about what we know is going to be happening here. We know that the nuclear membrane is going to be breaking down. We can draw that. And we're going to have to do that again. And we know we have our chromosomes moving out into the cytoplasm. They're full X's because in meiosis, the first time around, they got separated from their homologous pair. And their homologous pairs are over here. And what else is happening? We know that the centrioles are forming at the poles. And we know spindle fibers are forming. That is a terrible centriole. It's like meiosis by kindergartner here. All right, so nuclear membrane breaking down. DNA moving into cytoplasm. Centrioles and spindle fibers forming. Okay, prophase 2. All right, before we get on to the next one, let's think about what's going to happen now. We have prophase and metaphase. Think for a second what's going to happen here. I'm envisioning metaphase, chromosomes lined up in the middle, right? Okay. Meiosis, metaphase 2. Now, the first time around, we had the homologous pairs lined up in the center. But now they're each in their own cell, so we're just going to have a single line, just like in mitosis. 1, 2. And our chromosomes, our full X's, should be lined up in the center, in the middle. Okay, let's go back for a second to prophase. If we're going to label chromatid, how many are we putting in here? How many are in that one? If you're thinking 46, you are thinking correct. and 46 chromatid over here. And that will be the same. And that will be the same over here. And here. All right, what am I missing here? Right, we have the centrioles, which are on the poles, and they should be attaching to the centromeres. And hopefully you see where this is going now, coming up for anaphase. These are attaching to each one of them. Each spindle fiber is attaching to a centromere. It's essential that the correct number of chromosomes go to each pole. Whoop, that one got lost. There we go. Okay. I'm not going to type what, you should be able to type what's going on here. Chromosomes lined up in the center. Spindle fibers attaching. We know this phase is over as soon as those chromosomes start to pull away. And when they start to go away, you guessed it, that means we're in anaphase. So meiosis, anaphase 2. Now this one, I can't use the pre-made circle because I remember this time. What else is also beginning here? You guessed it, cytokinesis 2 begins. So I'm going to have to hand draw this. Everyone be aware. And I should draw a little cleavage furrow. A little cleavage furrow. And I gotta draw another one. A melted gummy bear. Oh, gosh. Perfect. All right, now, our chromosomes are starting to get pulled away from each other. Now, I'm only drawing 3, but we know there's way more than that. The spindle fibers are retracting towards the centrioles. Okay, we'll draw them in, going back, going back, going back. These I drew the wrong way. Now you have to watch me erase. Torturous. Try and do it quickly. This way, this way, this way, that way, that way, that way. All right, spindle fibers coming back. Spindle fibers coming back. I may have to switch to a mouse because it's just torturous doing this on the keypad. I tried doing the mouse yesterday and it didn't go so well, so give me a second. We'll put a mouse in here. All right, let's see if this is any better. Moving back, moving back. Not much better. Moving back. All right, so how many are going this way? How many are going that way? Well, if there was 46 originally, and half of them are going that way and half of them are going this way, we get the magic number we were looking for, and that's 23 chromatid going that way. And 23 chromatid going this way. And over here, we have 23 chromatid going this way and 23 chromatid going that way. I don't know why that's up there. And that's what we're looking to get. We're looking at 23, and hopefully you can see here, I don't know where it's at, each cell is pinching in, and there's going to end up with 23 on this side and 23 on that side. And we should end up with 1, 2, 3, 4 cells, each of them with 23 chromatid. From our original one of 46, it duplicated its DNA, okay, which gave us 92 chromatid. But then 46 went into one cell and 46 went into another. And then each of them split, you end up with 23 and 23. Okay? So, meiosis. And we are now in telophase 2. Cytokinesis continues. Cytokinesis 2 continues. All right, so this should be even more deeper cleavage furrow. See if I can switch to this mouse and it'd be better. Only slightly better. Oh my. Okay. Cytokinesis 2. We should have a cell membrane returning, a cell membrane returning on each, because we want to trap those chromosomes in there so they don't get away. And they all should be shaped like that. I can't fit that many. But we know there's going to be 23 in each one. What else returns? Nucleolus, dark region, to make those proteins, to make those ribosomes, the ribosomes to make the proteins. Oh, that nucleolus is a little too big, oozing out of the side of the membrane. Can't have that. Nucleolus. Spindle fibers and centrioles disappearing. I'm not going to type the words here. You know what the words are. And if you don't know, I'll tell you. Nuclear membrane returns. Nucleolus returns. Spindle fibers and centrioles disappearing. Cleavage furrow deepens. And hopefully you can see here, you can even probably do this next drawing on your own. It's going to be cytokinesis 2, and we're going to have 1, 2, 3, 4 complete cells, each with 23 chromatid. Let's put that in there. 23 chromatid there. (23 chromatid in this one. 23 chromatid over here. 23 chromatid over there. Right there. All right. Meiosis. Cytokinesis 2. There should be 1, 2, 3, 4. And 1, 2, 3, 4 nuclei. And we'll throw some genetic material in each one. All of them a single V-shaped-ish. Having a hard time getting it in there. A single chromatid. And 23 in each one. Right. So this is when you're looking back at that salmon video, every one of those eggs from the female looked like this. Every one of the males looked like this with 23. And so that egg and that male cell, that male gamete, they were trying to meet up with the opposite sex 23 chromatid gamete. So that then there would be a total of 46, one from the male, one from the female. Okay, so if you look back at that video, each one of those cells looked like this. Then the new salmon would have a pair, 23 for mom and 23 for dad. So when you start to think of yourself and you say, I have my dad's eyes, well, then those eye chromosomes came from your dad right here, his 23. Now, your mom gave 23 chromosomes, and she gave eye chromosomes, but your dad's was more dominant or happened to randomly show up. Of the two, that's the one that your body used. So that's how you get traits from both your mom or your dad. And they got those traits for them moms and dads. So you say, well, I look like my grandmother or I look like my grandfather. That means those traits that were passed down on those genes from your grandfather to your father to you, those traits that were genetics for your grandfather may be more evident in you than they were your dad because they just happen to show up in you. So those traits get passed down through generations on those sides in those 23. Okay. All right. So if you did not watch the meiosis video yet, go ahead and watch that whole meiosis video. This should all hopefully make a little more sense to you. I'm also going to put in your Google Classroom a form that looks like this. It's student feedback. And what I'm looking for is feedback from you. Because feedback's important. Also, besides the facts for the science, which are great, I just haven't heard from you. And I miss kind of getting your thoughts and feelings. It's very difficult to do this through, talking to a computer here, talking to a camera. I want to feel as if I'm actually talking to you, my students. So if you can give me some feedback, that would be great. And anything that'll help me, questions about this format, things I should change, things are working, things are not working. I'm kind of just doing stuff here that I think might be helpful. If it's not helpful or something else would be, I'm more than happy to change it up because this is my first time doing this. This is like your first time doing this as well. So I'm open to suggestions or criticisms or things that are working. So there's a form in there, and I'll put that in the Google Classroom as well. I'll get to work now on the Science Facts podcast. Tomorrow I'm thinking of doing a virtual field trip using Google Earth, try to at least get us mentally out of where we are and going somewhere. So I'm going to work on that today and see if we can have a little virtual field trip tomorrow for science class. All right, everybody. Hopefully you're all well. It's a beautiful day out today. It's sunshiny, so maybe get out and get in that sunshine and get some fresh air and stay safe. Okay, everyone. So long.